Today we have a very interesting equation. We need to find x here, but what we have on the left hand side and on the right hand side is kind of infinite procedure. So on the left we have something, we're adding x, taking square root, we're adding x, taking square root, and so on. We repeat this till infinity. Now on the right hand side we have kind of a similar story, but only with multiplication. We have stuff multiplying by x, taking square root, multiplying by x, taking square root, and we repeat it infinite number of times. And we asked at what x left hand side is equal to the right hand side. So first of all we're going to start with the right hand side. But before we do, we need to remember some formulas from algebra when it comes to square roots and powers. First of all, square root of a, any a we want, is equals to a to the power of 1/2. Well, a is anything we want, but it cannot be negative. The other thing we need to know that if you have a and b to some power of p, it's the same as a to the power of p times b to the power of p. Third formula we need to know is that a to the power of p and taken to the power of q, it's the same as a to the power of p times q. So we can apply these formulas to the right hand side, and we'll find that the left side here is equal to the right hand side, which is x to the power of 1/2 plus 1/4 plus 1/8 and so on. This is an infinite series here. So how did we get to this? Well, first of all, notice that square root is 1/2, a to the power 1/2. And the second of all, remember that if you have the product to the power 1/2, it's the first term to the power 1/2, another term to the power 1/2, and that's what we have here. That's square root of x times this. So it means that it's square root of x, which is x to the power 1/2 times square root of this square root. Now square root is power 1/2. So really what we have here is what's written right here on the second square root. That's called a here. That's going to be under 1 square root, which is p equals to 1/2. And then going to be on the top of it another square root, this one here. It's q of 1/2. So the result is a to the power of 1/2 times 1/2, which is a to the power 1/4. So we're taking x to the power 1/4, this one, times another square root, which gives us power 1/8. And we just continue repeating this process. At the end of the day, we have x to the power 1/2 times x to the power 1/4 times x to the power 1/8, and so on. And here we can apply a formula which I didn't write here, and that is when you have x to one power times x to another power times x to the third power and so on. That equals to x to the power of the sum of all these powers. And that's what we have here. Now it will be good if you figure out what this infinite sum is. But this infinite sum, if you look at it, is the sum of terms of geometric progression, or it's also called geometric series. Now we can go and find the formula for geometric series. You can do that, or you just can know a more general formula, or formula that's easy to remember, and that's this formula, that 1 over 1 minus a equals 1 plus a plus x squared plus a cubed and so on. The formula is correct for a between -1 and 1. So we can apply this formula to this exponent, and the way we're going to do it, we're going to take the exponent, add 1 and subtract 1. When we add 1, what we have in the front is exactly what we have here, assuming that a equals to 1/2. So applying this formula, we get the beginning is this, and then we subtract 1. And when you do the math, you find that this equals to 1. So essentially we have x to the power of 1, which equals to x, and that's what our right-hand side is. Now let's deal with the left-hand side. In the left-hand side, we have a bunch of summation and taking square roots. Now what we need to notice is that if you look at this whole thing, and then we look at the second square root, we find because this dot 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 is an infinite repeated procedure, whole thing, big thing, and what we have here are the same things. Well, why this is the case? Because if this dot 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 was something finite, those two things would be different. But because it's repeated infinite number of times, really it doesn't matter whether you have infinite number of times or infinite plus one number of times. It doesn't matter in this case. So what you have here and what you have here should be the same. Essentially, if you repeated this procedure infinite number of times and you got to this point, then you edit x and square it out, and you find that it didn't really matter. Okay, whatever you had here and whatever you got at the end is exactly the same thing. But that means that what we have here is x. Whole thing is x, so this thing also has to be x. And we got a much more simple equation, that is square root of x plus x. We combine those x's, we get square root of 2x equals x. The standard procedure in this case is to square this equation. We get quadratic equation, which we can easily solve. It's actually easy to see the solutions, or you can use formula for quadratic equation. It's up to you, but the solutions are 0 and 2. Now, here we have to be a little bit careful, because normally when you square some equations, you could get some extraneous solutions. So at the end of the day, when we found the solution of this equation, we have to take these solutions and plug it back in this equation and see if they still work. And we can easily check and see, yes, they did work. So we found that our original equation has two solutions, 0 and 2. And that's it.